this is Huck. Ekaterina asked me to do, just give you my thoughts about the math challenges, so here it goes. The first one about the Basugan bog, we call it a swamp, in at least this area of North America we say swamp, but it's either way, the bog worked too. I've actually never seen a real bog before. I live in a desert, so it was interesting to learn about the importance of it. What I would have liked to see from the challenge, at least the presentation, to learn a little bit more about the bog, would have been to see, I would have liked to see maybe a picture of the bog and maybe a map showing the location of where the bog is sitting. I can show you that right here. It made me want to look up the information, so I just got on Wikipedia and looked it up real fast about the bog here. And yeah, so there's a picture, and so just seeing that makes me understand that, yeah, it might be a little bit ugly for people to see, but the importance of it for the ecosystem and for the air we breathe was made clear by your presentation. So I really liked what you did there. As far as the mathematics goes, let's just see what we can do here. Well, based off of what you provided, I have that the area of Switzerland equals about is the same as the area of the bog, and that the Alps are 61% of the area of Switzerland. So the area of the Alps in Switzerland is approximately equal to 32,330 kilometers squared. So given that information, I basically figured out that the total area of the bog, or Switzerland, multiplied by 61% of that total area is going to give us 32,330 kilometers squared, which is the area of the Alps. So to solve for my unknown total area, TA I called it, I just divided by 0.61, which is the 61%, and that gave me 53,000 kilometers squared. Double checking on Wikipedia, the answers seem to be right. So that's my response for the first one. Once again, thanks for the challenge, and I look forward to more of them. Okay, hello again. This is my response for the second video about the Peter I monument that was constructed. Again, in this presentation, in this challenge, I would have loved to see a picture of the monument, and I would have loved to know why people were upset or not happy or neutral or happy about the monument. I'm assuming it's either a political issue, they didn't agree with something Peter I stood for, or maybe the Navy, or they just didn't like the location, or they didn't think it was beautiful. They thought it was an ugly statue. I would have liked to know the reason. I did, in fact, look up a little bit about it just so I can get to see it a little bit. So there it goes. Maybe you could have included with your presentation a website link or an article about the monument, so that those that were interested in your challenge could pursue the information further to learn more about it, as well as doing the math. So that being said, just you can check to see if my math is right, if this is what you were going for. Alright, so here we have the monument. What's given is the population percentage, their reaction, and all the way down to the bottom, the total number of population that at the time that this poll was taken. So I drew little pictures for unhappy, or upset, kind of unhappy, neutral, and happy. Woohoo! And then my math was, what I did is I took the total population and multiplied it by the decimal of the fraction. So 1.15 for 15%, 0.3 for 30%, 0.40 for 40%. Oh, should have changed that. Yeah, I just wrote it wrong, but I think I did the math right. So that should say 4. And then, again, this one is the same for 15%. So I hope that was right. I hope that's what you're going for. And let me know if that's incorrect. And yeah, I look forward to your next math challenge. Thank you very much for the presentation. It was a little bit hard for me to understand, so it helped to have the dialogue that you were reading so I could read along with you as you were speaking it. So again, thank you. Okay, this is for the third and final math challenge for the day. So again, I want to just thank you, all three of you, for doing the math challenge and for sending it out and just trying really hard. I understand that it's really hard to learn a second language, so keep going. I guess keep practicing. It's a different thing entirely to speak a different language and speak the language of mathematics, and so I understand what you're going through. Okay, so the Mound of Immortality. I really enjoyed looking into this one. I was curious about it, and so I decided to again look it up online. And so I just there's a picture of it. At least I think that's the one that you were talking about. I realized that when I looked it up online, there was a few of them, but it was also intriguing to kind of learn about why it was built in memory of the fallen heroes of World War II that tried to defend the country as Nazi Germany invaded. So it's a really cool story, and thanks for sharing that. Again, I would have loved to have some sort of reference to it, maybe an article that you read about it. I also was curious as to how they made it. You mentioned that the youth, or the young people, donated a lot of their time to build it, but how was it built? Was it just out of dirt, just that kept piling up, or cement? Is there cement underneath? So that'd be interesting to know, and maybe you could include that in your presentation. Again, the English was good, and it was a little hard to understand in parts, so it helped to have the dialogue in front of me to read it. As far as the math goes, yours was the most challenging, especially because it required me to remember formulas that I haven't used in a long time. But I think I have it right. Maybe you can test my math and make sure I got it right. So here we go. Okay, so here we are, the Mound of Immortality. First of all, what I didn't know, which was really helpful, was what it looked like. You gave me the volume and the height. But what I didn't know was the shape of the Mound of Immortality. I had actually envisioned a rectangular monument of some sort out of cement, like a wall or a big building of some sort. And so for this one especially, you need to mention that the mound is in a shape of a regular cone, or a near perfect cone. So once I saw the picture, I understood that we are working with a cone, and so you gave me the volume, and so I understood that the volume of a cone, a regular cone, is 1/3 times pi times the radius squared times the height. Okay, and again you gave me the height and the volume, so I solved for the radius. Now, you were asking for the surface area. When you say total area, I would encourage you to remember to say surface area when you're working with three-dimensional shapes like cones, spheres, prisms. stuff like that. So again, that's one thing I would change about your presentation. Just include saying what is the surface area, okay, if that's what you were asking me to do. So here's my methods for solving for the radius, and I got that the radius was equal to the square root of 5,000 over pi meters. I didn't actually calculate the exact number out, but that is an exact number, so I'm okay with that. So I didn't get the decimal, I guess is what I should say. So now, following that arrow up, loop, there we are. Now I knew that the surface area formula for the cone is actually given as pi times the radius times the side of that cone, the length of the side, plus pi times the radius squared. And that's taking into account the circle at the bottom and the cone shape on top. Now, we may want to also think that the surface area of our mound is actually just the part that's showing, so ultimately I'd probably want to not include the area of the circle on the bottom, because that's kind of silly to think about. Regardless, here we go. So assuming the mound is a near regular cone or a perfect cone, I actually had to find the side of that cone, the sloping side, right here, that S, by using the Pythagorean theorem, okay, which is a squared plus b squared equals c squared. I know this is going long, but I hope this is helpful for you. So I knew that the height was 12 meters, and I knew that my radius, which could be thought of as my base of my triangle, is the square root of 5,000 over pi meters. So the side, here's how I've figured out what C is, or what S is, and that's the one I got right there. The square root of 144 pi plus 5,000 all over pi. Okay, plugging that back into S, and I used my calculator at this point, I got that the surface area is approximately equal to 10,221.3 meters squared. Again, that was taking into account the bottom circle of our mound, so I probably need to actually subtract 5,000, which was the circle's surface area, from that number, and that would give me 5,221.3 meters squared as the total surface area of the Mound of Immortality. Okay, so very, very challenging mathematical problem. I really enjoyed it, and I want to thank you for putting the time into it. I look forward to your next math challenge. Thanks. Bye.